Today's learning intention is evaluating logarithms. Our essential skills are working with powers and indices. So let's get started. Let's recap on what are exponential functions. Well, here's an example of an exponential function. It's in the form y equals a to the power x, and for this case a is a number bigger than 1, and that gives us a growth function. Okay, as x is increasing, then also y is increasing, the function's increasing, it's growing. We can also have decay functions as shown here. It's still in the form y equals a to the power x, however a is now a number between 0 and 1, so it's a fraction, and that gives us a decay function. Now there's two important points on these graphs we need to note. We need to note that exponential functions always cut the y-axis at the point 0, 1. Now this is because when x is 0, the function equals a to the power 0, and a number to the power 0 is always equal to 1. Another important point to note is the point 1a, and that's because when x is 1, then the function at 1 equals a to the power 1, which is just the number a itself. That's two important points to distinguish on any exponential function. So why did I start talking about exponential functions when we're meant to be learning about logarithmic functions? Well, logarithmic functions are the inverses of exponential functions. So on this graph we can see the exponential function y equals 2 to the power x. The pale blue dotted line gives me the line y equals x, and to have the logarithmic function y equals log x to the base 2, all we have to do is reflect the logarithmic function, the exponential function, in the line y equals x, and that produces a logarithmic function. So in general, log functions are in the form f of x equals log x to the base a. Now this is created by reflecting the function y equals a to the power x in the line y equals x. Now note that log functions always pass through the points 1, 0 and the point a1, and these are two special points that we need to remember. Now there's two special logarithms we need to know about. So if y equals a to the power x, then the inverse function is log y to the base a, which equals x. In point 1, since a to the power 0 equals 1, it follows that log 1 to the base a must equal 0. In point 2, since a to the power 1 equals a, then it must also follow that log a to the base a equals 1, and this is really important. Now let's go back at point 1 and fill in some examples. So if log 1 to the base 4 equals 0, and that's because 4 to the power 0 equals 1. Log 1 to the base 8 equals 0, and that's because 8 to the power 0 equals 1. And log 1 to the base 10 also equals 0, and again that's because 10 to the power 0 equals 1. Point 2 then, here's some more examples for you. So log 4 to the base 4 equals 1, and that's because 4 to the power 1 equals 4. Log 10 to the base 10 equals 1, and that's because 10 to the power 1 equals 10. Now I wish I could just use a pointer on this to actually show you what happens here. Okay, but if we're at the bottom here and we're looking at the base 10, always say 10 to the power 1 equals 10. And log 3 to the base 3 equals 1, and that's because 3 to the power 1 equals 3. So we're always thinking in reverse, and your teacher will show you that on the board. It'll make more sense if I can have a pointer on this PowerPoint. So evaluating logs, right, let's think about this. Here's some examples. Okay, write these down in your notes. Example 1. So I want to evaluate log 16 to the base 2. In my head, I say to myself, 2 to the power what equals 16? So 2 squared is 4, 2 cubes 8, 2 to the power 4 equals 16. Okay, so the answer is 4. So log 16 to the base 2 equals 4. Example 2. So I want to evaluate log 9 to the base 3. In my head I say to myself 3 to the power what equals 9? So 3 squared equals 9. So the answer is log 9 to the base 3 must equal 2. Example 3. What about log 0.1 to the base 10? What's that going to equal? That's harder now. Okay, remember 0.1 is a tenth. So 10 to the power of what equals 0.1? Is this making any sense? Okay, 10 to the power 1 equals 10. Okay, what about 10 to the power negative 1? That would make sense then, because 10 to the power negative 1 is just 1 over 10, which is 0.1. So we have to be careful, it can get tricky. We have decimals, we convert to fractions. When we get a fraction, we think of a negative index. Let's try example 4. So log 5 to the base 25 equals what? So 25 to the power of what equals 5? Okay, that's going to be hard. So I'm thinking, well, the square root of 25 is 5. And how to get a square root as an index? It's going to be a half. So log 5 to the base 25 equals a half, and that's because 25 to the power of a half is the same as the square root of 25, and that equals 5. I hope this all makes sense. It's now time for you to try some on your own. So try these for examples on your own. Take your time, think about it. Okay, and when you're ready, I'm going to pause just now, and when you're ready, come back and I'll go over the answers with you. Right, I'll start to go over the answers now. Hope you've finished them all. Now make sure you've actually tried them before you just look at the answers, right? No cheating. So example 1, I have got log 32 to the base 2 equals what? Well, 2 to the power something equals 32, and then going through all my indices. So 2 squared is 4, 2 cubes 8, 2 to the power 4 equals 16. Next one up is 5. Okay, so log 32 to the base 2 equals 5, and that's because 2 to the power 5 equals 32. So you could only evaluate logs if you know the exponential. So example 2, log 256 to the base 4 equals something. So I'm now thinking of 4 to the power of what equals 256. We have to spend time doing this. You should get 4. Okay, because 4 to the power 4 equals 256. So log 2 to the base 8 equals something. Okay, so 8 to the power of what equals 2? That's quite hard. I know the cubed root of 8 is 2. How do I write the cubed root? The cubed root is just a third. Okay. So log 2 to the base 8 equals a third, because 8 to the power a third equals a cubed root of 8, which equals 2. Last one. Log of 1 over 64 to the base 4 equals what? So 4 to the power something equals 1 over 64. Now I know 4 squared is 16. And what's 4 cubed? 4 cubed 64. It is. So that would be negative 3. Okay. So log 1 over 64 to the base 4 equals negative 3. And that's because 4 to the power negative 3 is 1 over 4 cubed, which is 1 over 64. So how did you get on? Have a think about it. Any questions, ask your teacher in class, and we'll do some more examples with you. So this is your progress. How did you get on? Now, if you need extra practice, why not try page 295 of your textbook, exercise 15E. Pick and choose what questions you want to do and mark from the back, even just to check that you know what you're doing. So what have we learned today? Well, you've learned how to evaluate logarithm functions, or logs for short. You follow the following steps. So point 1, a log function is the inverse of an exponential. Point 2, if y equals a to the power x, that's your exponential function, then the inverse is going to be log y to the base a equals x. 2 important points then. So a to the power 0 equals 1, then it follows through that log 1 to the base a equals 0. And since a to the power 1 equals a, It also follows that log a to the base a equals 1, so that's important. If you're evaluating the log of a number and it's got the same base, then the answer is always 1.